Hi guys! Today I want to find out what I can rip out of an old PC power supply. I don't need it anymore and it's also a bit faulty. I found out that the 12 volt here has a ripple on it, and anyways, it's an older power supply, but I'm sure there's something inside I can reuse for other projects. So let's find out. Okay, let's see. All screws are out here, so let's see if it comes apart. And yes, it reveals the inner parts. We'll zoom in a bit. See, that's a bit too much zoom here. Yeah, that's it. And I already see, of course, there's a fan. Maybe I can use this for other projects here. It's a bit dusty here, but after some cleaning, if the bearings are good and it's silent enough, I can use it for other cooling projects. And I can check if these capacitors here are still good. It's 200 volts, 470 microfarads. Maybe it's worth to salvage them, but I have to measure that. And then there's a rectifier capable of rectifying at least 230 volts AC. And there's a fuse, 6.3 amps, rated for 250 volts. So of course this fuse can be reused for something else. And then we have two heat sinks, and heat sinks can be pretty useful. Maybe I will salvage them as well, and let us see. Of course, the cabling here has a lot of good copper in it, and it's flexible cables. It's really useful, and it has a sufficient length also. As you see, I stretch this here. That's pretty nice length, and yet it has a good size also, because of course it has to provide all the current to the main board. Let me see. It's let me see. It's 18 AWG. Yeah, that's nice. And there's more cabling here, and also a connector, a switch. That's the power switch. And the switch, of course, it can be used for something else, because it's rated for 230 volts, I think. Let me see. It goes here to the mains connector, so it should be possible to use it on a 230 volt AC application. That's nice. And of course, there's the cables already attached for this. That's good. Okay, the most important tool here. First I just rip out this switch here. It has 3 points of connection, blue and, oh no, it's 4 of them. Oh no, even more. So it's also white and a black cable. Anyways, it has to go away. The green-yellow cable as well. What else is left here? Yeah, just the black one. I want to cut it as long as possible, of course. Okay, now I got it. So that's the cable with the switch. And yeah, of course the cables are pretty easy to get out here because yeah, they are just soldered here. As you see here, they're just soldered directly to the PCB. And I don't make the effort to desolder it, I just cut them off. That's 1, 2, 3, 4, 5, 6, 7 cables here for the red connections. Really a lot of plus 5 volts connections because the red ones yeah, carry the 5 volt supply and the yellow the 12 volt supply, and black is ground, of course. So let's cut the yellow as the next. There we have it, and the black ones. Okay, there are even more black ones. And more and more. Oh my god. But of course, yeah, the black cables carry the return current for the 12 volt as well as the 5 volt supply. So of course there need to be more black cables. And then we have a blue cable here. I don't know if that's the yeah, the minus 5 volt. I'm not sure about that. But then I should be able to just pull it out. But no, there's a white cable. The white cable goes here to the mainboard connector. I'm not sure. That's the minus 12 volt. Anyways, it has to come out. The brown cable as well. So now the cable harness is free, and that's cable I can reuse for other projects. It's really nice. So that I don't have to buy them. So if you don't mind, make a small donation, because of course I have not all cable colors and all copper sizes here, or cable sizes. Would be nice to add other cables here, but for this I need money. Okay, what is next? I mean, it would be possible to salvage these components here, the sockets, IEC sockets for power supply, but currently I don't have any need for this. But anyways, I have to take the PCB out, I think, because otherwise I'm not possible to desolder any of the components here. Okay, let's see what ICs do we have in here. Okay, let's get the cable out of the way, then we have a closer look on this one. And that's KA7500B. And what else do we have here? An LM393N. Okay, so let's have a look on the datasheet here. Okay, I found this datasheet of the KA7500B. I see not of the manufacturer SEC, but of Fairchild, SEMI, and several manufacturers manufactured this IC type, and it should be quite similar. So as I expected, it's a switch mode power supply controller. And let's see what the features are, if it's worth salvaging. It has a reference supply trim to 5%. 5% is not so impressive. 1% would be better. Okay, and here I found the datasheet for the LM393N from Motorola, actually. And it's a low offset voltage dual comparator. Let's see what it can do for us, if it's if it's worth of salvaging. So dual independent precision voltage comparator. Precision is good. Capable of single or split supply operation, that's also good. These devices are designed to permit a common mode range to ground level with a single supply operation. Input offset voltage specification as low as 2 millivolts make this device an excellent selection for many applications in consumer automotive and industrial electronics. Wide single supply range 2 volts to 36 volts. Yeah, that's really impressive. Split supply range 1 volt to 18 volts, so half of it. Okay, that's expected. Very low current drain independent of supply voltage. Oh, that's pretty low. 400 microamps. That's good. Low input bias current, blah blah blah. Low input offset voltage 5 millivolts. Yeah, depends on the application. 5 volt could be okay. Input common mode range to ground level, that's good. It has ESD clamps to protect it from ESD events. And I like it when datasheets show the representative schematic diagram. It's nice to see. I mean, it's not possible to build the circuit from this because that's a simplified circuit diagram, of course, and these transistors with 2 collectors are not available on the market as a discrete part. And let's see if there's something remarkable here. Output saturation voltage, VN, we think. Okay, the lowest value, output value is 150 millivolts typically, and max 700. Okay, that's not so impressive. Sometimes it's really useful if you can go on the output lower to 0. Let's see. Yeah, I mean, it's not a special part. It does its job, but I think it's maybe not worth to desolder it. But yeah, I like when datasheets show these example circuits for several applications. Yeah, for example, the zero crossing detector. I mean, of course, you could build this with this tiny little IC and just some resistors and a diode. Or it's possible to make a free running square wave oscillator. Also, just with the IC, a couple of resistors and a small capacitor. And that gives then, this output voltage here with the rectangles signal. Or a time delay generator. That could be useful sometimes. For example, on an application with a microcontroller, if you don't have a startup timer, but usually the microcontrollers nowadays have a startup timer, because otherwise you could use it to hold the reset line down until a certain time has elapsed. So to make sure that the microcontroller startup is accurate. Comparator with hysteresis. I mean, that's basic stuff here. But if you don't have such an comparator here on hand, it might be worth to salvage this, but I think I have several comparators and I don't think that I will salvage it, because it's not worth it, for me at least. Okay guys, have you seen the ICs here, the switch mode power supply controller and the comparator are not very impressive regarding the specs, so I don't think it's worth to take it out. But there's still hope that the MOSFETs, which are mounted to these heatsinks here, might be of good use for later projects. But to get to these I have to take out the main board here first. Okay, I think that's all. Yeah, the PCB is loose, but there's still the ventilator here connected with these cables here. I have to cut these loose as well. Okay, it's loose. So I think it should be possible to take it out. It's still attached with these cables, but it doesn't bother me right now. So that's the soldering side, and you can clearly see the different parts and the big gap here which is intended for isolation between the 230. Let's see which side here. Yeah, between the 230 side and the low voltage side to get security, so that the 230 doesn't creep over here and potentially harm humans. Okay, yeah, you see that the heatsink is actually screwed here to secure it. And yeah, here's where the MOSFETs are soldered. And I think I have to desolder them, otherwise I cannot see what it is. But oh wait, oh no, it's really nearly impossible to see. Okay, I unscrew the heatsink here, both heatsinks now. One and two. So I can now desolder the soldering points of the MOSFETs on the left side. I have my desoldering iron, or solder iron, and desoldering tool here. Let's see how good this works.
One eternity later.
But at least now I can bend the heatsink a bit back so I can see what kind of part this is, and it's a I have to clean them. Okay, with that here I can clean the housing of the transistors or MOSFETs from the dust, so I have a chance to identify them. And yeah, I don't know if you can see that. It's hard to see on camera, but the left one is an 2SC26. Yeah, 2625. Also 2SC2625. And the other one is just the same. So 2 times the 2SC2625. Let's look what it is, if it is worth to desoldering it. Believe it or not, yeah, the 2SC2625 is an NPN transistor, bipolar transistor, not a MOSFET at all. That's really disappointing. So obviously, yeah, this whole power supply is so cheaply constructed with the cheapest available parts on the market that so far no part is really worth of salvaging. I mean, let's hope that the other side, on the low voltage side, maybe, yeah, it's better, but yeah, hopes are fainting down. Let's see if I can have a glimpse on the part number here. Again, it's really tight. Okay, So the left part here, that's diode. Yeah, if it would be a Schottky diode, it might be interesting, but I highly doubt it. And the other side, this part here is what is it? Yeah, I mean, the easiest thing to salvage is this fuse. Okay, salvaged. But I think I will leave the rest as it is. It's just not worth the effort. It's sad, but it is as it is. I'll just yeah, put that back in here. Okay, quickly put on the cover again. And then I think that's it. Thanks for watching, and if you're not already a valued subscriber, you have now the chance to become one. And yeah, stay tuned for more videos. And yeah, again, if you don't mind, yeah, just make a small donation. I think my material is worth it. You can watch it for free, and the channel is not monetized or not monetizable at all. I don't earn any money with it. The channel just costs money, and yeah, to compensate that a bit, I really please you to make just a small donation as you can afford it. Yeah, details see on the end card. And then I will see you next time. Bye bye.